Okay, let's get started. I'm not sure why the stream is just like a little slow today. I'll have to look into that after. Yeah, I'm not really sure what the problem is, but hopefully I'm not going to be dropping any like rendered frames. Um, so like for instance, there's no reason why this should just be 60 FPS. But anyways, um, let's start. So today, what I'd like to work on is sorry, um, is doing the color conversions with SIMD. So I also would like to add something here. So output color to standard out when closing, and um, allow input or allow displayed color to be specified via command line. And what that's going to allow us to do is just you can basically make like an editor plugin that would like in Vis, for instance, you're editing like a color, you could like pop up the color picker for that color and then like tweak it, and then when you close it, you could load that back into the file and save it. I think that'd be pretty cool. First, we want to do this. So write those notes. We are going to open up the colorpicker.c and I don't know what's going on with the rendering today, huh? Probably Gentoo's broke something again, as it is on Linux. In any case, so which one's it? Which I want to do either. Let me just think here. So HSV to RGB is okay. HSV to RGB is pretty easy. It's from RGB, sorry. Looking at the Wikipedia page here for where these conversions are. Yeah, so let's do HSV to RGB first. So we've got like these conversions here and stuff, which are like kind of dumb, and get rid of those altogether, which will be nice. So let me just put a comment here. So f of k is equal to value minus value times saturation times the maximum of 0 and the minimum of k 4 minus k and 1. And maybe even better, we'll just type this as it needs to be typed in C. Why is there? Oh yeah, okay, never mind. That looks correct. And then so here, A is equal to really should be f of n. Well, f of, let's call it f of k of n. Let's go a little mathy here. So k of n is just going to be equal to n plus h over 60, assuming that h was in degrees. So in degrees from 0 to 360, but I think the way I'm storing it is from 0 to 1. So actually what's going to happen here is it's going to be h times 6. So this should change its range from to 0 to 60, and then this whole thing mod 6, but really it's mod f6, not just mod, not integer mod, but anyways, that's fine. Maybe I could specify it as like that, just like mod f this and 6. And then the output would be RG B is just going to be equal to, let's do this, let's line this up, keep everything nice. That's just going to be f of 5, f of 3, and f of 1. So this gives us like a nice little equation here to just do SIMD on 4 floating point values. So let us start. So first of all, we'll just use like 128 SSE registers for this, because it's just 4 floating point values. Go to the Intel Intrinsics guide. I need to open that one up. I will post that one in the chat as well. And try to remember to link it in the video, but so what we care here, we're going to use SSE instructions only, and we need M 128. It's 2 underscores. We're going to need so we're going to need HSV K and N. We're going to need all of those. I think that's all we need here. And we'll need 6. Actually, we need 6 for 2 different things. That's like nice. So that's actually really nice. Yeah. So let's just start here. Let's do look at the load instructions here. You can either do there was like an extended version of this. I don't know if I care about using the extended ones or not, but it's just be all of these, right? Yeah. So there's different ways of doing this. Probably the easiest is just to use some C literal. So what we want to do is so what we're going to do here is we're going to say that 6 is equal to mm load PS, and it's going to be 32 pointer. And it's gonna be 6, 6, 6, 6. And then it's like other instructions. Maybe I should look at like the swizzle operations. The swizzle actually may be what I'm more of what I'm looking for. Maybe not. So I thought there was like broadcast. I think that's only for AVX 256, like AVX instructions. Yeah. I don't know if there's like a broadcast instruction for um SSE. I don't think there really is. There's like MM set one. I don't know. I could try that. I don't know which one of these is gonna be worse or better, to be honest. So let's comment this out and we'll just try like the MM set one PS. And we'll do 6. We could do this for all of these. For a bunch of these, I guess, anyways. So let me think here. What do we want to do? So we want to do yeah, we've got our n here, so we do n. N is gonna be actually the lone one. We'll do an F32 pointer. We'll do 5, 3, 1, and 0. We have to figure out how to just make sure that the I think like this operation here will basically just make sure that the 0. Oh wait, no, so the alpha. And when you like the alpha just get propagated through. How can we do that from this expression? So if the alpha I might not be able to just do it super easily here. That's okay. Yeah, so I don't think that the alpha is just gonna show up too well. Probably just have to do it at the end, which is fine. So it probably doesn't matter what we stick in the fourth element for a lot of these, but we'll see. Okay. So then next we need, so we got our 6, we got our n. So now we want to compute need V at S and H. We need all of those, so let's just do it. Let me just see here. H, this is going to be equal to load set 1 PS, and then HSV dot XYZ, basically. So Y, Z, this is going to be V, V, and this is the S. So we got all of those loaded up. And then with all of those loaded up, the next thing we're going to want to do is compute k. So k is equal to now so mod is maybe not one that's even available unless you use it's like what's like this? So we might have to just compute mod ourselves. Like there's special math functions, but these probably are not. Oh no, so we can use the special math functions. We just can't use the mod directly. So unless it's called like remainder or something. Yeah, I don't think, I do not think. I think I'll have to do the mod myself. Is okay. The difference is like, well, float mod is like kind of weird, right? So hello, Army Larry. We are computing. We're doing HSV conversion using SIMD. But I need to just figure out how to do mod. I forgot how to do. So mod F specifically is special. These functions shall return the signed fractional part of x. No, most of the online hosting is free. I usually combine. I use like both GitHub and I have my own hosting as well, but I host all my stuff on my own website as well, but you can get it wherever you want. Let me just think here. So K, right, so K, oops. So K we're gonna do separately here. So K is equal to venture capital, I guess. I don't know. No idea. Most of them I don't think serve ads, so yeah, I'm not really too sure. I doubt their enterprise customers can support the whole thing. Um, we're gonna do add ps and then n and um, mol ps 6 and h. And then we're gonna do I have to do this mod. So to do mod, what is mod f? What does the function mod f actually compute? Or just like, what's the, let me see, like what's the function called in, oh, it's like f mod. That's what I was thinking of. So f mod, so these functions shall return the value x minus x, or sorry, x minus I times y for some integer I, such that if y is non-zero, the result has the same sign as x and the magnitude less than the magnitude of y. So we have to right. That's like a little complicated to calculate, isn't it? Advertise Rust as a feature. I don't know. I'm not a Rustation, so not too sure. So this is actually like a complicated thing to just do properly. Um, we have to like we need to compute basically what we need to do is compute like what's actually the return value here. It's like a fractional value. I don't really care about all these other possible issues. What I do care about, though, these functions. So these are like vector instructions. They're not part of any library. They're just like wrappers around assembly functions, basically. um, you can look them like most of them up in this repost it here. Oh, the man page. This is just math. This is just in normal math. Like the normal math.h, like libc math. Yeah. So you have to find like the closest. You have to find the closest multiple of x that's 6. So here we are doing n plus h times 6. So h so okay, so h is guaranteed to be a multiple of 6. But n, when you just go and add n, I times y. So in our case here, where h was normalized beforehand, um, let me just see this again. So for some integer I such that if y is non-zero, the result of the same sign as, oh sorry. Yeah, so if y is non-zero, some integer I, oh, that's just like IEEE floating point. Yeah, that's IEEE floating point, nan. I don't actually care about nan in this case at all. It shouldn't, it won't show up at all in this case. But, yeah, so this is funny. So x, sorry, so x is n plus h times 6. I guess I can just like sub in the whole thing here. So what we want is this, but the f mod x y is this. In our case, x is n plus h times 6. And so really we have this minus I times 6, which can just be like refactored to give n plus h minus I times 6. Um, well, I mean that in this case, like the reasons why this function would just return nan. So this h value can't be nan. It has to be between 0 and 1. So this case is already wrong, impossible. Y in this function I'm just doing y is 6. So y cannot be 0. X can't be infinite. X could be 0, but this is not returning an n. So neither of these are infinite. So the only case here is like this one. So yeah, there's like no way that this can just give like a nan for the calculation I'm just doing. So I don't need to like think about that at all. Right. So then what's I? I is an integer, but H is between 0 and 1. So what that just means is that an N is also an integer. But in this case, well, I'm not sure. Like, so, oops. I'm not sure why. Like, my computer seems like a little laggy today with like the rendering. Um, so if I wasn't streaming, this would definitely say 60, but it should still be 60. But for some reason, the rendering's just taking like really long. Um, right now, I'm not really sure. I have to look into it after the stream. Because definitely this program's not doing anything that would make it be slow. Okay, so for some integer I such that if y is non-zero, the result has the same sign as x and a magnitude less than the magnitude of y. I'm pretty sure I can just literally, I could just be straight up. It should have the same sign as x. So x was positive. If h is just 1, which is its maximum, and I is huh. Let me just think, check this quickly. Is it just oh, so you can just truncate. There's like a truncate instruction. So I guess if you use like round with a specific rounding mode and you just truncate it. Yeah, okay. So I'm like way overthinking this. Um, so yeah, what this should just return is sub yes k and then uh round ps um so what's the rounding? So the rounding should be yeah, round to negative infinity. And then x over y. So yeah, mm div, what's it called? Yeah, just div ps. K and are we doing mod with 6? 6. Add an extra one of them. That should be correct now for the K. Oops, it's weirdly lined up. And then, okay, so now we've got K. Now we can just do this straight up because min and max and all that just exists. Oops. We want not that. Not this one. Min PS. So, okay, oops. Also we need 4 and 1. So let's make some more dumb variables here called 4 and 1. Let's just do this. Move all this stuff around. Most of this we'll look at the assembly after, but I think most of this is going to be optimized out, but we'll see. We might have to turn optimization on to see that. It's okay. Okay, and then we need to do this is going to be min PS. Let's do this. Oh, and 0. Sure. Why not? Well, we're at it. Might as well. Okay. Let's do it this way. Max 0 and min min right, min yes, yes, let's do this. This is getting too much. Too much for one line. Four and K. And this is with 1 and T 0. Okay. This can't be this anymore. It needs to be T. And then just these multiplications. So the result is just going to be V and, well, this is starting to get too much again. So let's do mol PS V and let's do T, sorry, and what do we got here? S and V. And then sub, so what we got here? We got T, and then this one, okay, and T. And that is going to be the result. And then what we need to do is just so ideally I should just load, well, I don't need to load alpha really, to be honest. We can just and then we just do a, what's it called? Load a store. Gotta store the result. Just be like, why is that like? Okay. Store yes. Probably debating if I want to just use a line out, but anyways, that's fine for now. We'll just do this. So rgba.e and where's the yeah, and then result. So we'll just do that. And then what we'll do is do rgba.a is equal to hsv.a. And we'll just return that. Let's see here. We're going to get some undeclared identifiers because I've not included any of the required headers, which is good. Probably this one goes there. And let's see, is that enough? Well, yeah, that would be good. So let's go back here. I don't need to go into the header. I don't care about that. M128, M128. Okay, fine. All those ints, those are not ints, but sure. Okay, oops, X. Okay, almost there. Sub TS, there we go. That should be all of that. And of course the color is going to be wrong. What would happen to the, that's weird. Let's go and step through the code and see what's going on, I think. Let's go over here and we'll bring up the color picker. We're gonna break here. Let's kill and then grab. I think if this would like break where it's supposed to break, but doesn't want to break there. Fine, so be it. Let's look at the where are we here? Why is this like okay, I might have to just like rebuild this without the debug thing. I thought I've had this working before in the there, like maybe I need to do like shared library. I mean, let me just check the build script, I guess, and see if, oh, yeah, that would explain the problems. So now if we do this, um, of course it would generate invalid code for that one and just give me a nice sig fault. Let's do this way. What's this called? And val. Let's do this. Okay, so well, yeah, it's not causing a bunch of lag, but it probably is. Let's break there. Why is that like doing that every frame? That's weird. Oh, I didn't hit the breakpoint yet. Now I've hit the breakpoint. Okay, so this is gonna look like some spaghetti probably, but that's okay. Let's just step through it. That's given that 4 4 1 1 0. That's making it in just fine. We're gonna add 5, 3, 1, and 0. So that looks correct to me. So 5, 3, 1, and 0. So like, yeah, there's like some weird rounding going on there, but that's okay. This is where it makes more sense to like break this into like separate steps, but that's fine. Also, if we do like this, yeah, well, actually, yeah, compiler just like converted it to the wrong instructions, but and it's doing a bunch of garbage unless you enable optimizations. So, anyways, um, now what is K? So K should just be I mean, that seems like reasonable. Um, so 4 should be the minimum between 4k, 4 minus k. So looks all correct. And then 1. Yeah, so that looks good. But that would explain why this is just getting compressed like this. So you just look at this formula again. So it should be like the minimum of I'm missing like a minimum here. No, I'm not. Right here. Minimum of k and t. So that's correct. That part's correct. Was I just like, let me just do this. No, here I was just converting it to 0 to 360. The formula wants it to be between 0 and 6. So, yeah, so multiplying by 6 is just correct. Let's go next. Yeah, I mean, that result makes sense. And then you're just going to get the value showing up, which is obviously not what you want, but yes, why is that getting truncated when it is bigger? Just continue. Probably have to get rid of that breakpoint for now. Let's just continue. So let me just remember what's going on in the sliders here. So when we're in the mode of current, this all looks correct. If we're like current mode, we are just doing that, adjusting in the HSV space. And then yeah, that's fine. When we do the fill HSV image, so what we're doing in here for any of them. Yeah, that is what we had to do. So that would make sense. This is in HSV to RGB. So why is this value always getting converted to that? So let me just let me see. Do I need to break this up so I can actually see what's going on with this modulo thing? I kind of should break that up. Let's have a look. See. Yeah, let's do this. So let's go back to running. And we're into breakpoint, and we're gonna continue until we hit the breakpoint. Not sure why we're hitting that breakpoint every frame though. That doesn't really make a lot of sense to me. Have to see why in a second. Let's skip down here until we get to K here. So what we should be getting after the mod is just like 1.49 and then 5.49, 3.49, 2.49 if everything's just working. It's not. So what happened there? It's gonna be like this. So if we divide by 6, so we had 7.49 I can do this with like BC, so it's visible. BC scale equals 10. 7.496 divided by 6 is that. And then we round to negative infinity, so that's going to give a 1. We need to multiply the result by 6. Need to multiply the result of this rounding by 6. Well, so technically HSV and RGB are the questionably different color spaces, but yeah, I do plan on doing RGB to like lab later. So isn't sRGB just like floating point RGB and then like I don't know. I could be wrong. I will look. Um yeah. I'm not sure it like even matters though, right? For like this situation, I don't know. But like so if you consider like an RGB let me just get rid of this breakpoint and just rerun this. Oops, on that window. So if you just consider like an 8-bit RGB value and then you convert it to floating point by dividing by 255, like the whole time it would just be the same as being an S. You've already like narrowed the color space to 8 bits, so like I'm not sure it matters. I mean, I could be wrong. I'm not an expert on colors. Um, yeah, I mean, I can definitely look into it afterwards. Um, or does like OpenGL just do the conversion itself like automatically? That might actually be the case behind the scenes. I'm not actually sure. Um, in any case, I should fix this bug first. So, OpenGL has to be told which color space it's using. Yeah, I'll have to look into it. When you're putting in color. I'll have to read into it a little bit more, I think. Remainder. Move that over there, and then we'll do that should be that. There we go. Yeah. Sure, I will just open that in the window here, and I will look at that right after I'm done, possibly. Oops, do not. Okay, yeah, I will definitely look at that. Anyways, that fixed that bug so that at least this part is working again. Probably I want to do this a little bit differently, but let me see. Let me compile this with the only problem is that Clang is going to convert all of this to 256 probably. Just do a build here and then what I want to do is do HSV to RGB. Yeah, so like Clang just converts all of this to AVX instructions instead of the normal. It's a bit annoying. It also has like way too many moves. I don't think I need to like see the color. Like the equation I just used is like correct, assuming sRGB. So I just need to make sure the rest of the stuff stored in sRGB rather than linear. If I just enable optimizations, then some of that's gonna get like cleaned up, but don't want to like. Yeah, it just gets inlined, which is really annoying. The whole thing just got inlined, so so I do want to like do the XYZ conversion so that I could have like a lab mode. Um, yeah, yeah. Definitely I want to do that. Just not this time probably. Um, Probably I don't need to also rat hole too hard on what the assembly is happening for this right now, but might be easier to just use like go what's it called? Godbolt.org or .com or whatever. It's .com or .org. Yeah, godbolt.org. Let's actually do that instead, and then we have a better idea of what's going on. So if we, let me see here, do this and then zoom like way in, 300, 200 is probably good. And then open the color picker.c and we'll just copy all this. And we'll have to do a bit of massaging that way. So I have to get rid of this. Probably I can put this below. So I need to do a little bit of massaging here. Flow struct of a float. It's float x, y, z, w. And struct of float because I use both of them in this code. And a float e4 so that's looking correct for that, and then I need to include and even oops. What is the problem? Oh, oops. I didn't actually name this. There we go. And align as should be in C mode. Okay. And then that should be better. Let's go to Clang now. What is the complaint that align at, oh, that's actually the complaint. Where is the options? This is not gonna work on this one, right? Okay, look, good enough. Good enough. So let's get rid of this. Yeah, so it just converts it all into AVX instructions instead of oh, I guess like these aren't AVX instructions. I guess they just like renamed the Interesting. Okay. Let's use O1 so it doesn't do so much stupid stuff. So like O3 is even shorter. That's like the same length. So yeah, actually I think it's like the same thing in O1 or O3. Just copy this. Let's just do this. No, not this. This is not what I want it to do. Why don't you want to copy properly? Okay. Okay, it doesn't need to be. Please. Why is that not working properly? Okay. Thank you. And then we can just do that. Okay, so that's that one in O1. And then with O3, I think it's just the exact same. It's just O0 does like not the stupid stuff. So let me see here. Oops. We have got it's like 21 lines. 21 lines. So yeah, it's just like the same thing. O3 versus O1. It's just without the with no optimization, it doesn't compress some of like these extra moves and whatever stuff I'm just doing. Yeah, there we go. So I don't know what like the raylib. We could look at like what the raylib implementation is. Let me see. So raylib probably in our core, and it would be have to just cd there and just use the old egg. That would help if I could spell it right. So that's in our textures actually. Actually, it should be color from HSV that I'm interested in right now, which would be in. Oops. Color from HSV. So Raylib's doing like that same formula, except they're doing a bunch of duplicate work. So I'd actually be interested to see what the library code comes out for this one. Where did this get installed? Here, yeah. Color from HSV. Here it is. Hello, Terrace. How are you? So color from HSV here is some, well, suffice to say, it's significantly more than 21 lines of assembly. With like jumps and branches and all that sort of nonsense. Whereas here's this 21 lines of straight branchless assembly. So yeah. Basically, the version I just wrote is significantly faster without even, analyzing anything there. Yeah, so that's good. What OS am I using? I'm using just like Linux, like Gentoo Linux, but it doesn't really matter. So that's pretty cool, I would say. Let me see here. So yeah, I don't think I care about doing this anymore. Let me just do a color from HSV. Let's see, where are we using this still? We're using it for doing some lerping. That should still work, right? Yeah, so let me get rid of these altogether. These are just 3 of them. Yeah, I don't need to use this here at all. What am I just trying to do here? To color normalize. HSV to RGB. Dot ray back. That would be correct. Oops, color from normalize is what I wanted there, not color normalize. Do I use Homebrew? Isn't that something for like Mac OS? From normalized. Thank you. Okay, so that is still working. I also can close this tab. That tab doesn't need to be open. Let's do that. You use Homebrew on Linux. I'm not sure why you would use it on Linux. Yeah, I don't know why you'd want to do that. Okay, so we're done with that one, so that's better. Now, where's the other color from HSVs? from HSV. Just these three. I'll get rid of these. But I mean, I could just get them from like my normal package manager, right? Like, why would I need a separate package manager to do that? Um, let's do this one. So let me see. Got HSV. Well, let me see. So like the lazy way to do this would to be uh um I I don't think most people on Linux would be using Homebrew, so um like if your tool's like available, um usually I think most people would just submit it to whatever Linux distribution they're using. I don't know. I've never actually done it. I've written like e-builds, but I also just usually install my own software without a package manager. What am I doing here? So I want to just use my conversion here. So yeah, let me do this. Make a temp variable. And we're not going to use param anymore. And then down here, we're going to do hsv.x is equal to temp. And we're going to get rid of param in a second. And here we're going to do hsv.x. Here we're going to do v4 rgb equals, well, so we'll do this. We'll still do the RGB, but it'll be color from normalized HSV to RGB HSV dot ravec. We're gonna do that everywhere here. So here we're gonna do temp equals HSV dot y. HSV dot y equals 0. HSV dot y equals temp. And then down here. Okay, and copy this one. And param is not used anymore, so we can delete that. Temp up there for no reason other than I can. That's looking good. Besides that, whatever just happened there, which is not supposed to happen. Uh, wait, why did that happen? Huh? It's only happening for the first one. Um, how did that even happen? What? How did that happen? That's really strange. What did I just do that would make that happen? That doesn't make any sense. Let me just try this. Go back. Go back. What would happen there? Okay. Yeah. Go back to this. Not sure why that's happening. Just try this down here again. Let's just add the temp variable. Yeah, so don't need that. Um, like the S is still working fine. Then this should also just be working fine, I would assume. if I just HSV.Z that, why would that not work? Yeah, so that's like fine. Then why did the HSV.X just break? Param plus equals 360 over image width. This is exactly the same as it was before. What? So I think I need to check. There might be like some rounding error or something going on. Weird. Yeah, why is that happening? Try the old OG. Yeah, what is going on there? That's like yeah, let me go into this and just step through that one. So that would be here. I don't know if that's gonna show up in the old thing. Just killed it and just run again. I might not. Should. Maybe it will. Continue. Okay, so that's in the fill HSV. So if we do that, let's go to fill. Bunch of stuff's optimized out, so could be a problem. Let me see. Yeah, so this is not the code that I need to see, unfortunately. That's not gonna help too much, is it? Um, hmm, weird. So that is annoying, but we will just do I'll have to look into that one. I think I'm going to probably call it for now and try to figure out uh why everything's so laggy today. um so let me see here. Let's take the win. For now that's okay. We'll just leave those ones as is because Like the alpha slider still works fine. Okay. Yeah, let me call it there. So let me just commit. Um, okay, cool. So I'll push that in a second here. Thanks everyone for watching, and I will see you all next time. Bye.